welcome back. As promised, this is the third problem that I like to point out on the concept of Arrhenius acid-base theory concepts. Now, as with the previous case, this is a strong acid. So if you go back to the list of 6 acids I gave, sulfuric acid is one of them, and this is a strong base. Okay. Now, what is important here is, as I said, what do you look for in a chemical equation? Now, the equation, the arrow is single-headed. That should tell you that both your components must be strong, which we have already identified. So that's 2 checkpoints. But the third thing is, the intro video also said, is your equation balanced? Well, most likely it's not, all right? So what I'm going to do is rewrite this equation in a different color and then balance it out, okay? So that's why I'm doing it in this mode. So H2SO4 plus NaOH. Now this is not at all new. We did this in Chem 170 when we were discussing stoichiometry. This was done there for a different reason. Now it's done for a different reason, but it's all interrelated, all right? That's what I want you to take from my class. If you're going to be successful in chemistry, you just have to see the concepts as interrelated. That's the way I'm teaching it, so you should be able to see it, all right? So if you balance this equation, this is 1, this is 2, this is 1, and I believe this should be, let's see how many hydrogens we got, 2, 2, 4, so it should be 2. So this is a balanced equation. Again, I'm not going to write the aqueous liquid because I'm just showing up that it's balanced. It's always what's on, you need to focus only really on the reactant side, okay? Because the product side rarely does not, once you balance, it doesn't really matter all that much, okay? So I'm going to box this, okay? Now you see that the acid and base is not 1-to-1. The acid is 1:2 for base, okay? It's asking for equivalence point. So you are welcome to use the same equation. And I believe only 30% of the class got this question right on the final exam on 170, which by no reason is an excuse, because this is probably one of the easiest questions you will ever see on any exam, all right? So we're going back at it again. So I hope this time around the batting has improved and I see more people getting this question right, all right? So we know volume of acid. Let's not focus so much on the numbers yet, but what it is we have to make a subtle difference to this expression before we can use the numbers, right? Now, you only use it as it is when it's all 1-to-1-to-1, but it's not 1-to-1, it's 1-to-2, right? If the base has a 2, you multiply the acid side by 2. Does that make sense? If your base is 2, what you're trying to do is compensate for what it's not, all right? So if the base contains the 2, you multiply the acid times by 2. You first make this adjustment before you even proceed to solve the number. And I know some of you got actually some unreliable numbers, as I gave some random numbers as answer choices and you went for it. There's no way in the world, even if you had not adjusted for it, you would have got those as answers. So you probably were just guessing. So with that said, you have to account for this adjustment. If you don't multiply by 2, which I most probably will not, and that will be one of the answer choices. Let me repeat, if you don't use the 2 times, that's only for this. Why? Because the base contains 2. Say if let's write the alternate. So say your acid is 2 and the base is 1. There is a case which I have tested that also on the quiz, not on the exam. So in that case, V acid times C acid equals V base times C base, right? Well, this time the acids got the 2, so you multiply the base by 2. And I have repeatedly said this, and I even walked up to some of you in the lab and said this is probably one of the easiest problems on the exam. And I guess maybe you thought I was joking, but it was there. And I think only a fraction of the class got it right. But anyways, you got to know this because we're going to be doing a lot of titration. We're going to be doing a lot of chemical equilibrium related labs. And it's not possible for me to sit and explain every time that you have to multiply by 2 or multiply by 3. All right. So I've said this once, and this is the last time I'm going to say this. All right. So now you go punch in the numbers. All right. Let's say we got volume of acid is 50, because that's what's tagged to the sulfuric acid, and sulfuric acid is acid because I just said sulfuric acid is acid, right? And concentration of acid is 0.15 molar. Volume of base, well, as I said, equivalence point typically refers to volume. In this case, because the volume of acids provided, it's got to be the base that we need to solve, and concentration of base is given to you as 0.25. Now, the numbers won't be the same because in the previous case, we saw that the strength, again, the strength of acid and base does not matter because we're dealing with equivalence point, but the ratio does matter. I mentioned that. So 2 times volume of acid is 50, concentration of acid is 0.15 equals volume of base, we don't know, concentration of base is 0.25 molar. Put all that in and get the base. Now you will see that it's different. So 2 times 50 times 0.15 divided by 0.25. So it's 60, which makes sense, right? We got 30 last time. We just got 60 this time. And I gave on the exam, not the same numbers, but I gave without the 2, and most of you went for it if you have at least thought of this equation. In fact, this equation was in the appendix, just not multiplied by 2. That's the only thing you have to add, and I don't think many of you did that. Now, the point here is sulfuric acid contains 2H+, which is what the definition of Arrhenius is. It generates H+, because there's H2. Proton can only be H+, because there's 2 protons, there's 2H+, there's only 1 OH, so 1 OH minus, okay? Which is why we are multiplying by 2 here, okay? Because, again, you can just do it from the balanced equation. If the base contains the 2, you multiply by acid. If the acid contains the 2, you multiply by base. Again, Arrhenius theory fits best in the context of titration, which is why I chose to do that first. And of course, this problem is very important. If you're going to think, if you're thinking of MCAT or pharmacy, perhaps nursing down the road, then these are concepts that's very, very important for you. If you're going to be interested in taking GRE, and probably not so much, unless you chose to become get a PhD or master's in chemistry, then all this stuff has to be known. And we just wrapped up Arrhenius acid-base theory. As I said, it's the least complicated of the 3. And we're going to get into the world of Laurie-Bronsted acid theory, and we're going to be on it for a while. So get ready for it.